Hey guys, so today what we're gonna do is we're gonna attempt this beautiful and crispy past paper that has been designed by Cambridge for your upcoming May-June 2023 examinations, because the syllabus has changed a wee bit, and that's why they have given you a specimen paper in order for you guys to have an idea of how or what type of questions could be asked. But 95% of the questions asked would be the same because the syllabus has just changed by a tiny bit. Okay? So without further ado, I'll just write my name, which is Suleiman, and Khan, like the Britishers say, right? Not Khan, Khan, okay? And let's solve these questions. So question number 1 says, a gaseous substance is slowly cooled and the temperature recorded every second. The results are shown on the graph. Okay, so this is basically a cooling curve, which, what does a cooling curve tells you? Obviously, what the question is saying, a cooling curve tells you how the temperature of a substance changes once you cool it down, right? So it says it was a gaseous substance, so at A it would be a gas. Now at B you have a horizontal line, right? And horizontal line means that the temperature is constant, it's not changing. And we know that when the temperature is constant on a heating or a cooling curve, that means that there's going to be a change in state. Now obviously, since you're cooling the substance down, that means that the gas would actually start to move slower, start to come closer together. The intermolecular force of attraction would start to become stronger, and it would be converted into a liquid at the constant temperature bit. And we call this process condensation. Why? Because condensation is the process at which a gas changes its state into a liquid, and this constant temperature is actually called the condensation point, the constant temperature at which a gas changes its state into a liquid. Now obviously a liquid has been formed here, and then at C you're just further cooling that liquid down, right? And at D again the temperature is constant. That means that the liquid is going to start to change its state into a solid substance, right? So we call this process freezing, and freezing point is this constant temperature at which a liquid changes its state into a solid. Now what is the question asking us? It's asking us at which point is the substance a solid. Obviously at point number D, Reno. Okay? Now I didn't need to go into a lot of detail about for this question, but it's good to understand the information that you could deduce from questions while you are doing practice, right? In your paper you could have just circled D, because you know that gas, and this will be liquid, that's with the liquid cooling down, and then here it will be a solid, the liquid changing state into solid. That's your choice, but I'd recommend to try to deduce as much information while you're doing practice papers. Okay? Question 2 says, a gas is released at point Q in the apparatus shown. Which gas changes the color of? So you have to change the color, that's one thing, and you have to change it the most quickly. And damp universal indicator paper is actually green in color, because damp means you've added water to it, and water is neutral, that's why it's going to be green. And the color of universal indicator are ROIG BIV, right, which stands for red, orange, yellow, green, blue, indigo, violet. Red, orange, yellow bit are in acidic, and your blue, indigo, violet bit are in your basic solutions, right? Or basic agar koi cheez ho, that'll give you this color. And green is for a neutral like H2O or hydrogen. Okay? Now saying which gas changes the color of the dance. Okay, so you're given gases. We know that quickly depends on diffusion, and diffusion depends on temperature and the relative molecular mass of those gas particles. And we know that temperature, information about temperature has not been given, so we just have to consider the relative molecular mass, which are given right here. Now the least the relative molecular mass, or the lowest relative molecular mass, would diffuse the fastest, right? So lowest kya hai? You have hydrogen, which is the lowest, then ammonia, then carbon dioxide, then chlorine. But you also have to understand that it needs to change the color of damp universal indicator, and hydrogen, it has no effect on the damp universal indicator's colors, because it's also a neutral gas. Okay? So it's not going to change the color. Chlorine on the other hand would bleach it. Carbon dioxide would go towards the acidic bit, so like orangish, yellowish, and ammonia is basic, so it would go towards the blue, indigo, violetish bit. But since hydrogen does not change the color, we eliminate this option, and between the three options available, we know that ammonia has the least relative molecular mass, therefore it would diffuse the fastest, and it would change the color the most quickly. Okay? Question 3 says, which statement describes the bonding in sodium chloride? Sodium chloride has ionic bonding in it, in which you have ions. There's a strong so what am I saying? There's a strong electrostatic force of attraction which holds these ions together, these oppositely charged ions together, right? So we have to check this out, which which option is giving us this. Now A says a shared pair of electrons. No, it's not shared. It's a transfer of metals to transfer of electron from metals to non-metals, forming oppositely oppositely charged ions held together by strong electrostatic forces of attraction. Okay? B says a strong force of attraction between oppositely charged ions. Yes, sir, that's the right option. But let's see C and D for a moment. C says it's a strong force of attraction between two molecules. No, they are ions, not molecules. Okay? And D says a weak force. No, it's a strong force of attraction. So C and D are therefore wrong. That's why B is the right option. Question 4 says the lead in a pencil is made up of a mixture of graphite and clay. Obviously, when the percentage of graphite is increased, so if you increase the percentage of graphite, this lead would actually be a little more slippery. You could use it. That's how sketch brushes are actually made. Sketch brushes, not sketch pencils, right? So you use different percentages of graphite in them. And obviously saying if you increase the percentage of graphite, the pencil will move more easily across the paper. The reason is because graphite has layers which can slip over each other, and that's why it can be used as a lubricant, because it reduces friction. Now it's saying which statement explains this observation. It has a high melting point. It does, but it does not explain this observation. It is a form of carbon. Again, does not explain this observation. It's a non-metal. Again, does not explain this observation. The only thing that explains this observation is that graphite is in fact a lubricant. Therefore, it reduces friction, and that is the reason why the pencil can move across the paper more easily. Question 5 says which statement about metals is not correct? They conduct electricity because of delocalized electrons that can move throughout the metal. Yes, that's true. They do. Absolutely. Metals have C of delocalized electron. That's how they can conduct electricity. They consist of layers of atoms that can slide over each other, and that's the reason why metals are malleable and ductile, because the layers can slide over each other. So B is also true. Part C says they have a giant lattice of oppositely charged, and that's wrong. They have a giant lattice, but it's not about oppositely charged ions. It's a giant lattice of positive ions in a sea of delocalized. Okay, oppositely charged ions means that you have a positive ion and negative ions, and we know that negative ions, they don't exist in metallic lattices. Okay, you have electrons and positive ions only. My bad, what am I doing? So that is therefore C is the right option. Not the right option, but they're asking you what is not correct, right? So C is not correct. That's why C is the right option, although C is saying something wrong. And D is the right option. D is like telling you the truth, which says they have a giant lattice of positive ions in a sea of delocalized. And that's absolutely right. Now aqueous iron sulfate, which is Fe2SO4 whole thrice. How do I know that? Iron has iron 3 here, that's the oxidation state, so it's going to form an ion of 3 plus. SO4 is 2 minus, cross multiply, you get Fe2SO4. It's saying, and sodium hydroxide react together. Sodium hydroxide, Na is plus, OH is minus, cross multiply, you get NaOH. They react together to give you guys iron hydroxide. Iron hydroxide's formula, iron is again 3 plus, hydroxide is minus, cross multiply, you get FeOH thrice. And then what else is formed? It's saying it forms a sodium sulfate solution. Sodium is plus, SO4 is 2 minus, cross multiply. I don't know why my voice is breaking again and again. So Na2SO4. Let me clear my throat. Yes, now it's fine. So that's the equation. It's saying what is the balanced symbol equation for this reaction. Now, how do you write a balanced equation? You could do two things. You could check the atoms of iron and on the left hand side and on the right hand side, and they should be equal, or you could just balance the equation yourself. You could do it by saying, oh, you have 2 irons on the left hand side, therefore you should have 2 on the right. So you have 1. In fact, you have 1. So how do you make it into 2? What do you multiply 1 with to get 2? X is equal to 2, right? So 1 को मैं किससे multiply करूँ कि 2 आए? 2 से. So we insert our beautiful 2 right here. And if you check the equations out, if you check this bit, where can you see a 2? You can only see it in option C. So directly option C is your right answer, but you could further balance it if you want. You have 3 sulfates on the left hand side, therefore you should have 3 on the right. But how many do you have? You only have 1. So what should you multiply 1 with to get 3? X is equals to 3, right? So 3 will be inserted right here. And then you have 3 times 2, you have 6 sodiums and on the right, but you only have 1 on the left. So what do you multiply 1 with to get 6? You multiply it with 6, and that's the entire balance equation, which is shown by AC Areno. Yeah. Question 7 says, which information is needed to calculate the relative atomic mass of an element? How did we calculate the ARs? It was the average mass of the isotopes of the same element relative to 1/12 of a carbon atom, where carbon is exactly 12 units. And how would we calculate it? Like, for example, chlorine was Cl, you had 2 isotopes of chlorine, one was 35 and one was 37, and then we needed its abundance, right? So this was in 75% abundance and this was in 25% abundance. Then we took the average, and therefore we were landed with 35.5. So what were we doing? We needed the mass numbers and we needed the percentage abundance to actually find out the ARs, right? So what do we need? We need the total number of protons and neutrons in the most abundant. I don't know, we need it for all the isotopes, right? Because protons and neutrons are equal to the mass number. That would be true if it had stated not in the most abundant isotope, but in all the isotopes. The nucleon number and the total number of isotopes. The nucleon number is right, because nucleon number again is the mass number, right? That's another name for it. But total number of isotopes, you also need the abundance. That's why B is wrong. C says the mass number or the nucleon number and abundance of each of its isotope. Yes, we need the abundance and we need the mass number. D says the atomic number. Atomic number is the number of protons, right? So we don't use the number of protons. We use the nucleon number or the mass number, which is basically protons plus neutrons, not just protons. So D is also wrong. Question 8 says, the equation for the reaction between sodium carbonate and excess dilute hydrochloric acid is shown. Beautiful. It says, when 26.5 grams of sodium carbonate reacts with excess what is the maximum mass of carbon dioxide produced? So you're given information about sodium carbonate and you need to find out the volume of carbon dioxide produced. And we've learned in stoichiometry, what we do is we've been given the mass of sodium carbonate, we go into the moles of sodium carbonate, and we use a relationship for that. And then from moles of sodium carbonate, we go to the moles of carbon dioxide through the equation. And then from moles of carbon dioxide, we go to the volume of carbon dioxide through a relationship. Now, what is the relationship between mass and moles? It was molar mass. 1 mole of sodium carbonate would have how much mass? We could calculate that from the periodic table. Sodium is 23 times 2. Let me just calculate it. 23 times 2 is 46, plus carbon, which is 12, and plus 16 times 3, because 16 is oxygen, and times it by 3 because 3 are present, so that's 106 grams. So in 1 mole of sodium carbonate, you have 106 grams, and if you have 26.5 grams of sodium carbonate, how many moles would you have? You cross multiply 26.5 divided by 106, that'll give you 0.25. So you have 0, or you could just use the formula for it, right? So you have 0.25 moles of sodium carbonate. So we are here. Now we need to go from moles to moles, and we know that, and we could do that through the equation. So 1 mole of sodium carbonate is giving you 1 mole of carbon dioxide. So if you have 0.25 moles of sodium carbonate, it would give you 0.25 moles of carbon dioxide. And then in the end, you need to go into the volume of carbon dioxide. You know that 1 mole of any gas at room temperature and pressure would occupy a volume of 24 decimeter cubes. So if you have 0.25 moles, how much volume would it occupy? 0.25 times 24, that gives me 6 dm cubarino. A volumetric pipette is used to measure 25 centimeter cube of, so you are given the volume and concentration, you could find the moles out of it. How would you do that? You know that in 1 decimeter cube, you actually have 2 moles. So I could say you have 2 moles in one, rather than saying 1 decimeter cube, I could say 1000 centimeter cube, because the volume is given in terms of centimeter cube, right? So in 2 moles, you have 1000 centimeter cube. So if you have 25 centimeter cube, how many moles of sodium hydroxide would you have? That's X is equal to, you cross multiply 25 times 2 divided by 1000, that gives me 0.05. So you have 0.05 moles of sodium hydroxide. Now it says that the reaction requires 50 centimeter cube of dilute sulfuric acid to reach the end point, the point of neutralization. What is the concentration of dilute sulfuric acid? You found out the moles of sodium hydroxide. Now from the moles of sodium hydroxide, we just need to find out the moles of H2SO4, and we're already given the volume. Then we divide it and we get the concentration, right? So if you have, through the equation that 2 moles of NaOH gives you 1 mole of H2SO4. So 2 moles of NaOH reacts with 1 mole of H2SO4. So if you have 0.05 moles of NaOH, how much H2SO4 would you need? That's x. X is equal to cross multiply. It's 0.05 divided by 2. You get 0.025. These are how many moles of H2SO4 were used, and you need to find concentration, which is mole per decimeter cube. So first of all, convert this into decimeter cube, which is 50 over 1,000. That gives me 50 divided by 1,000 gives me 0.05. Now just divide the two. Mole per decimeter cube means divide the moles over the decimeter cube. So 0.025 divided by 0.05 decimeter cube. And what do we get? 0.025 divided by 0.05. That gives me 0.5 mole per decimeter cube, which is A. That's the concentration, that is A. You could have also used the formulas, but I just like to do cross multiplication, yeah? The diagram shows a circuit used to electrolyze aqueous copper sulfate, okay, which arrows indicate the movements of. So aqueous copper sulfate will have a copper 2 plus ions, SO4 2 minus ions, H plus ions, and OH minus ions, right? And since which would indicate the movement of copper ions in the electrolyte. Obviously, copper is positive, it would move towards the negative cathode. So 2 is the right indication. Therefore A and B are wrong. Between C and D, we have to also identify how the electrons are moving. The negative ions are going towards the anode, so they're going to lose the electrons right here. So the electrons move like this. They move from from the anode upwards, right, to this positive. And you could also use the common sense that electrons move from a negative terminal to a positive terminal. That could also be a reason, right? So 3 and 2 are the right options. That's why C is actually true. 11 says, which row shows waste products released from the exhaust of a vehicle powered using a hydrogen fuel cell? A hydrogen fuel cell does not have any waste except for H2O liquid. That's why we are trying to innovate new reasons, trying to innovate new, polymers or new, substances in order to make this efficient ताकि आगे जिंदगी में यही इस्तेमाल हो. So it does not have any carbon dioxide. That's because of these fuels. It does not give you nitrogen oxides of nitrogen. It only gives you water. That's why D is the right option. Which diagram shows a correctly labeled reaction for an endothermic reaction? For an endothermic reaction, we know that the bonds broken must be, the energy taken in during bond breaking must be greater than the energy given out during bond formation. Taken in should be greater than given out. Here the problem is that taken in is less than given out. Given out is more, taken in is less. Taken in is less, given out is more, right? So C and D are exothermic, not endo. Between A and B, we have to check the labeling. From reactants all the way to the top, you have the EA, and from the reactants to the products, you get the enthalpy change, which is the overall energy change. So A is the right option. What's wrong with B? They're saying that from the reactants all the way to the top, that's the enthalpy change, but that's wrong. The overall energy change, that's called enthalpy change. So that's wrong. That's why B is the wrong option. Question 13 says, which changes are physical changes? Melting of ice. Physical means that there is only a change in appearance, right? No chemical, no new product is formed, no chemical change, blah, blah, blah. So melting of ice to form water. Ice is also H2O, water is also H2O. So yes, that's a physical change. Burning hydrogen to form water. Now that's a chemical change, because burning hydrogen means hydrogen reacts with oxygen to give you H2O. Now a new product is being formed. That's why it's a chemical change. Adding sodium to water. If you add sodium to water, again, a chemical change would take place. Sodium hydroxide would be formed. That's why C3 is also wrong. Boiling water to form steam. Yes, water is H2O, and if you form steam, steam is also H2O. You just change the appearance. That's why 1 and 4 are the right options. B is therefore correct. Moving on. Question 14 says, the diagram shows an experiment used to measure the rate of a chemical reaction. Which change decreases rate? Heating the flask during the reaction would increase the rate of reaction, because increase in temperature does do that. Using a more concentrated acid, that increases the rate of reaction. Using a powdered metal, that means that you're increasing the surface area, which increases the rate of reaction. More collisions or more particle exports, blah, blah, blah. But A, and therefore A is basically the right option. But if you want to understand what A actually means, it means that if you add water to the flask, it will actually dilute this acid, right? So ye jo dilute hydrochloric acid aap isme dal it will further dilute it if you had added water to the flask, right? It would reduce the concentration of it. It would decrease the concentration of this already diluted HCl. That's how we know that decrease in concentration decreases the rate of reactions. That's the explanation to it. And you could also have done elimination method. Question 15 says, which row describes the effect of increasing concentration and increasing temperature on the collision between reacting parts? Increasing concentration results in more collisions per second, more collisions, as the time passes out. The frequency of collisions increases, but it does not change the amount of collisions with sufficient energy, right? We have done two things कि rate को दो चीजें affect करती. One is the change in frequency of collisions that actually is increased by cos, and one is increasing the collisions with sufficient, in the proportion of, if you guys remember, I've stated this, the proportion of particles that possess the EA. That is only done by temperature. That's why increasing the concentration by double increases the rate by 2. But if you double the temperature, it increases if you double the temperature, it increases the rate by more than 2, because temperature also gives the particles that energy, because temperature is a form of energy, right? So it gives those particles the sufficient energy to react, and it also results in more collisions per second because kinetic energy बढ़ जाती, so the frequency of collisions increases. That's why B is the right option. For here you have more collisions, for here you have collisions as well as collisions with sufficient energy to react. ठीक है? Methanol is prepared by reversible reaction as shown. Forward reaction is exo, so backward would obviously be endo. Which condition produces the highest equilibrium yield of methanol? We have to, maximize this. So by maximizing this means we have to favor exo, which means that there should be a lower temperature, because decrease or a lower temperature favors the exothermic bit. That's why B and A are wrong. And a pressure, if we talk about the pressure, increase in pressure favors less number of moles and decrease in pressure favors more number of moles of gas, right? So here you have 3 moles of gas, here you have 1 mole of gas. What should we do? We should increase the pressure, because increase in pressure favors less number of moles of gas. Why? We've discussed all of that stuff in class. When chlorine gas dissolves, it's asking about the oxidation state. Chlorine is its pure elemental form. It has an oxidation state of 0. In HCl, H is +1. Here it's always group 7 in a compound would be -1. So here it's -1. Here you have to find it. Let's call this X. Hydrogen is +1 and then oxygen is -2. You make this equation and overall oxidation state of any compound is going to be 0. So X -2 + 1 gives you -1 equals 0. X equals +1. So here Cl is +1, here it's -1, here it's actually 0. Okay? So if I want to check this out, C and A are wrong. 0, -1, +1, D is the right option. 4 different solutions, J, K, L, and M, are tested with universal indicator, which is ROIC, BIV, red, orange, green, blue, indigo, violet. Before green se pehle they are all acidic. After green, blue, indigo, violet, that indicates basic in nature, right? Which solutions are acidic? If it's red, orange, yellow, it's going to be acidic. So K is red and that's M is orange. Purple and green, no, purple is basic towards the indigo bit, green is neutral. So red and orange, K and M, that's the right option. Which solution has the lowest pH? The lowest pH means that it's going to be the most acidic. Let's check it out. Which one would be the most acidic, right? Ammonia solution is basic. Lithium hydroxide is basic. Between ethanoic acid and hydrochloric acid, we know that ethanoic acid is a weak acid and hydrochloric acid is the stronger acid. That's why we know that C would have a lowest pH. Magnesium, calcium, strontium, and barium are group 2 elements. Group 2 elements follow the same trends in reactivity as group 1, which means that the reactivity down the group would actually increase. Why? We've also discussed that in class, although it was not a part of your course, but we've discussed it. So reactivity of group 2 increases down the group, which means that calcium reacts faster than magnesium with water. Let's check group 2. Calcium is below magnesium. That's why it would react faster, because down the group the reactivity increases. So calcium would absolutely react faster than magnesium with water. So A is right. Then barium reacts less vigorously than magnesium. So it's saying barium reacts slowly than magnesium. Does it? If you check barium out, it's lower than magnesium. No, barium should react faster than magnesium because it's down the group. So B is actually wrong. This 2 statement is wrong. And third statement is strontium oxidizes in air more slowly than barium. Let's check strontium out. Strontium is above barium. That's why barium should oxidize more quicker than strontium. So yeah, that's true. So 1 and 3 is absolutely right. That's why C is the right option. Chlorine, bromine, and iodine are elements of group 7 of the periodic table. Which statement about these elements is correct? The color gets lighter down the group. No, it gets darker, right? Chlorine is a pale yellow gas, then it goes to, a red-brown liquid, then it goes to a solid iodine blackish solid, right? The density decreases. No, it increases, because which is more dense, a gas or a solid? You're going from a state of gas to a solid. Obviously, solid density is greater, so A and B are wrong. They're all gases at room temperature and pressure. No, that's a gas, that's a liquid, that's a solid, so C is wrong. They're all non-metals. Yes, that's true, because non-metal, the way you could identify non-metals is draw a staircase after boron, and the right of this staircase would actually contain all the non-metals, ठीक, and the left would contain metals, और बीच में कई metalloids हैं, but who cares, not a part of our course. Then which row describes the property of a typical transition metal? Melting points of a transition metal is high. It does have a variable oxidation state like iron 3 and iron 2. They have two different oxidation states and they act as catalyst. Absolutely. So high melting point, yes, and that's how yes, B is the right option. Which statement about noble gases is correct? Noble gases are diatomic gas. Diatomic means like chlorine. They're made up of two atoms, right? But that's not. They're monoatomic gases, not diatomic molecules, right? You have argon exists as Ar, not as Ar2, right? That's what diatomic means, कि दो atom की combination. So yes, they're not diatomic. That's wrong. Noble gases are reactive. Then why would they be known as noble? The reason why they call it noble is because they're sharif. They don't react, right? So B is wrong. And noble because they have a complete octet, right, or complete outermost electron shells, and that's what the next statement says. Noble gases have a full outer electron shell, and that is absolutely true. The noble gases are found on the left hand side. No, they're found on the right. So I'm like, what is this man saying? Like, why did ये option नहीं देते तो अच्छा होता? Like, lol, what is he saying, right? So noble gases are not found on the left hand side of the periodic table. We just need eyes to see that noble gases are actually here on the right side of the periodic table. Sometimes it makes me laugh, man, that by the options that the examiner gives you, O levels and IGCSE. What is the property of all metals? All metals, they do conduct electricity because they all have delocalized electrons. They are not all hard because like sodium is a soft metal, potassium is a soft metal. Mostly metals, pure metals are all soft. So B is wrong. Low melting point, no. Metals usually have high melting point. But, however, there are some metals which have low melting points. Exceptions are there. Reacts with water? No, not all metals reacts with water. Like, copper, silver, gold, they don't react with water because they are, they in the reactivity series, they are below hydrogen. So yes, A is true for all metals. Now, which statement explains why aluminum is used for the manufacture of aircraft? First of all, it was used because it had low density. Because it has low density, it helps in aerodynamics, right? So it conducts heat well. Why would it be used in aircraft? It has low density. Yes, that's why. It is a good insulator. No, it's a conductor. It's a metal. It's easy to recycle. Nobody cares, man. It's because of its density. The section of the reactivity series shown includes a newly discovered metal symbol X. X has a formula XO, which means it's like gonna be part of group 2, or it's gonna have an ion of 2 plus. Like let's suppose it's magnesium, right? Magnesium oxide would also have a formula MgO. Which equation shows a reaction which occurs? Now, if you check the reactivity, a hydrogen copper cannot react with H, right, and with X, right, and X cannot displace iron, magnesium, and calcium because it's lower in the reactivity series. So if you check this out, X cannot displace iron, it's lower in the reactivity series. That's why C is wrong. X can, copper ions, where is it? Copper cannot displace X because it's lower in reactivity series than X. So A is also wrong. Now between B and D, which could be true? Because the formula is XO, which means that it should have a charge of 2 plus. If you check B out, here the charge is shown as plus, right? It's not shown as 2 plus. That's why the only viable option is D. And if you check D out, it makes sense. Let's suppose X was magnesium, right? And how do you know? Because of the formula. Let's suppose it was magnesium. Let's suppose, because magnesium is not here, it's somewhere here, but let's suppose, okay? So if it was magnesium, it reacts with 2HCl to give you MgCl2 and plus hydrogen. And that is what you are getting, right? But obviously magnesium is above here. We're just assuming just to solve this question. Which metal compound produces a gas that turns lime water milky? Whichever would have the carbonate ion, because that's the test for carbonate, and that is copper carbonate, not magnesium nitrate, sulfate, or zinc nitrate. Which statement about the extraction of iron in blast furnace is correct? Calcium oxide reacts with basic impurities. No, it reacts with acidic impurities like silicon dioxide, जो sand है आपके पास, and it removes it by forming calcium silicate, right? So that's what it does, not with basic impurities, with acidic impurities. Carbon is burnt to provide heat. Yes, we've done that. It does. Iron oxide is reduced by iron. It's reduced to iron by carbon dioxide. No, it's reduced to iron by carbon or carbon monoxide. Carbon monoxide is actually formed, right? So Fe2O3 plus carbon or carbon monoxide gives you iron plus carbon dioxide, right? The raw materials are bauxite. No, bauxite नहीं होते हैं, hematite होते हैं. Bauxite is the raw ore for aluminum, right? It's actually aluminum oxide. So D is wrong, C is wrong. That's why B was the right option. An experiment to investigate the effect of painting iron is shown. The experiment is left for 7 days, so it's actually going to talk about rusting. What happens to the water level in test tubes X and Y? You have air here, you have water here. The one that is painted, the air, there would be no change in the amount of air, nothing would change. But you know, the one that is X right here, it has air, it's pure iron, it would rust, which means that it would react with the air and some of the, it would react with the air and it would rust. Therefore, air jab istemal hoga is test tube mein, what would happen is that the water level would rise. And the reason for that is because as soon as the air gets used up and reacts with this iron to undergo rusting, this air is going to be displaced by the water. Simple displacement reaction. If you remember over water delivery, that was what was happening, right? So aapke paas pani hota tha idhar, and what would happen is if you would pass the gas through it, the gas would start to collect here and displace the water outside. And if the gas is here automatically and it is getting used up, then the water would displace the gas, right? The water would displace the air. So water level would rise here and there would be no change in Y. So rises in test tube X, but no change in Y. That's why D is the right answer, because Y would not rust, right? Because you've painted iron, you've protected it from rusting. For rusting, you need air as well as pani, yeah? Bauxite contains aluminum oxide. Aluminum is extracted from blah, 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 blah. Which statement is the reason for why cryolite is used? It's an impurity which lowers the melting point, and that's how you use less energy. So cryolite lowers the melting point of the electrolyte mixture. B is the right option. It does not remove any impurity, right? It is an impurity itself. Which statement is correct? Atmospheric carbon dioxide is not a cause. That's so stupid. Atmospheric carbon dioxide anywhere is a cause of climate change. So A is wrong. Atmospheric carbon monoxide is produced by it's produced by incomplete combustion of carbon containing fuels. Burning natural gas decreases the level of natural gas is a fossil fuel, right? Natural gas is like largely methane. Methane, if it burns, it does not decrease carbon dioxide, it increases carbon dioxide and water. That's why there's a war on, you know, these fuels. Don't use these fuels, go towards the renewable source of energy. What are you saying, man? And then D says decomposition of vegetation causes an increase in atmospheric methane. Yes, that's how fossil fuels are from, the decay of vegetative matter, right? So we've discussed this. Therefore D and B, D is the right option and B and C were wrong. A plastic combusts to form sulfur dioxide and hydrogen chloride. Both are acidic. It says, how could both gases be removed from it? You just reacted with the base and there would be a neutralization reaction. Now pass the gases over anhydrous cobalt chloride. There's no sense for this. Anhydrous cobalt chloride was a test for water. Where is water here, right? There's no, like, तुक भी नहीं बनती यार इसकी. Pass the gases over damp calcium oxide. Yes, calcium oxide is a base and it would react with these gases to undergo a neutralization reaction and remove them from the air. So B is the right option. Pass the gases through a catalytic. No. You pass gases like carbon monoxide and nitrogen monoxide through catalytic converter, right, on unburnt hydrocarbons. Pass gases through filter paper. Filter paper se kya kaha? Filter paper actually traps residue, traps a solid. There is no solid, there are gases, man. So D is also wrong. Which equation represents the photosynthesis? We've been doing this since we were children. Photosynthesis mein carbon dioxide reacts with water under the effect of sunlight and chlorophyll to give you glucose and oxygen, and you just put a 6 everywhere to balance it. 666, the devil's number, right? But you could use your brain. You have 1 carbon here, you had 6 here. 1 को मैं किससे multiply करूँ कि 6 आए? Obviously with 6. You have 12 hydrogens here, you had 2 here. 2 को मैं किससे multiply करूँ कि 12 आए? Obviously 6. And how many oxygens did you have? 6 times 2, that's 12. 12 plus 6, that's 18. And 6 were already present, so you needed 12 more. So 2 को मैं किससे multiply करूँ कि 12 आए? X equals 6. Yeah. Which statement defines structural isomers? They are compounds with the same displaced formula but a different, no, they have the same molecular formula but different structural formula, right? That's why they are compounds with the same molecular formula but a different structural formula. So therefore C is the right option. If you look at B, it says they are compounds with the same molecular and displaced formula but a different structural formula. No, displayed formula and structural formula are essentially the same thing, because देखो आप displayed formula में क्या करते हो? We show all the bonds, right? And if you check, like, this is an isomer right here of butane. there's a difference in their displayed formula. One is drawn like this and one is drawn like this, you know, one is branched. So there's a difference in their displayed formula, and displayed formula is essentially what a structural formula stands for. Although there's a difference which I've discussed in the classes. Petroleum is a mixture of different hydrocarbons. How do you separate them? Through fractional distillation, man. No cracking. Cracking is used for alkanes. Combustion is just burning of fuel. Reduction is stupid. Which equation presents the reaction between methane and which is correct? Methane is here, you have Cl2 here. What would happen is a Cl would replace a hydrogen, substitute a hydrogen, and the hydrogen would bond with the Cl remaining. So what would form is H3Cl plus HCl gas, and that's why A is the right option. B is wrong because that's showing the addition reaction of alkene, and that's an alkane. Both chlorines cannot be added at the same time. Cl2, hydrogen, both chlorines cannot be added at the same time to substitute two hydrogens at the same time. So C is also wrong, and D is God knows what D is, right? So that's also wrong. Now 37 says ethanol can be produced by fermentation, blah blah blah, which shows an advantage of fermentation and an advantage of catalytic addition. Now fermentation का advantage है, it's a batch process. That's not an advantage, that's a disadvantage, because it's a batch process. That means it's going to be slow, right? That's not the advantage. Part B says it's a fast reaction. No, again, it's a slow reaction. Fermentation is very slow. It takes like 15 days to get at least, you know, some sort of alcohol out of it, and it's very dilute. वो आपको जो ethanol देता भी है वो भी dilute, इसको further fractional distillation करनी होती है. C says renewable raw material. Yes, so these two are the advantages, because, you know, fermentation is done through glucose, and glucose is renewable. Disadvantage, again, it's a batch process, and it also gives you impure ethanol in the sense that you have diluted ethanol. बहुत कम होता है, it's like less than 15%. You have to perform fractional distillation. So both these are correct. Let's look at the other box. Pure ethanol is formed in catalytic addition. Yes, it is. Pure ethanol is formed, and it's not a slow reaction. It's very, very fast. So C is wrong. That's not the disadvantage. It is a fast reaction. It's not a slow reaction. Again, the advantage is it's a fast reaction, and finite raw material is the disadvantage, because it's made up of alkenes, and alkenes are limiting. It's like they are fossil fuels, and they're gonna finish. So they are not renewable. They are non-renewable, which we call finite raw materials, not infinite, right? So that's why this is the correct disadvantage, and D is the right option. Part of the structure of polymer is shown. Which monomers is used? Just draw a cut after every 2 carbons and just remove the continuity bonds and draw a double bond between the 2 carbons. Double bond between the 2 carbons, CH3 right here. This was my Cl, that's my H, and that's my F. Remove the other bonds, right? These 2 bonds would be removed. That's why I'm putting a cut. These 2 bonds are removed, and in those bonds ki jagah either you'll have a double bond. So what is the structure? If you check this out, B is the right option. C3H, Cl, and F. Yes. 39 says 5. I'm just tired, man. 5 steps in an acid-based titration. So what is the correct steps of completion? Slowly add the acid. No, that's not the first. The first step is you use a volumetric pipette to add a fixed volume of alkali to a conical flask. Yes, that's the first step. I agree with this. I can call this a first step for now. Then it says add thiamolphytidine. Yes, then we add the indicator. That's the second step. And then what we do is we add the acid. And first of all, we add the acid to the burette. Then we read the initial volume. Then we slowly add the acid from the burette into the conical flask. And then we read the final volume reading to have a to subtract the two and find the volume of neutralization. So this is first, that's second, and then what you do is you record the initial volume, that's third, and then you add the acid to the conical flask, that's fourth, and that's fifth, right? So the third step is my first, so A and D are wrong, and the last step is basically the fifth one. That's why B is the right option. A student does paper chromatography. Why is he? What is the function of a locating agent? He uses it to identify amino acids because they are, you can't see the spots visibly. So you add like a locating agent. Usually ninhydrin is used, and ninhydrin gives you purple spots, which are very, very beautifully visible for the location of, to check out the spots of amino acids. Yeah. So to dissolve the amino acids, no sirree. To form colored spots with the amino acid, yes sir. And these are purple with ninhydrin. To preserve it, no. To stop the amino acids from reacting, no sir. So that was basically this past paper, and I feel like we've gotten 40 out of 40, no doubt. Yeah, full mark star for you guys. So that's how, I've discussed this in so much detail, although this was a past paper that could be done in like, let's suppose 20 minutes at max. 20 minutes. If you guys have taken my classes, surely you could have just solved this like bursting through it. But I went into detail discussing each and every question. Taki, if you guys still had any problem with the concepts, that would also revise. Take care, guys. Bye bye. I'm tired. Ciao. Allah Hafiz.